Alright, hello everyone. So in this video we want to look at sets in interval form. Okay, so we can represent different sets in interval form depending on what we are working on. So we have what we call the open interval, which you can also call open bracket. So you either call it open interval or open bracket. And what does that mean? So let's define it. If I have a comma b, that's equal to the set of all x in the set of real numbers such that a is less than x and x is less than b. Okay, so the open interval implies that you're looking for all the real numbers between a and b, in exception of a itself and b itself. So that means that number should be greater than a. Anything greater than a is there. So an example is if you are given something like let's say open interval 1, 5, right? So this is all x values that are greater than 1 but less than 5. In other words, the implication is that 2 is an element. So we can say that 2 is an element of this interval. Okay, so and that's actually what we want to achieve in this class, so that you are able to know how to represent sets in small intervals and not make them ambiguous. Okay, so the second one, we have what we call the closed intervals. Okay, so I'm first of all bringing out the extremes. So the open interval and the closed interval are the extremes. Meanwhile, we have about 4 types of intervals, but you can reduce them to 3, but then they are majorly 4. Okay, so this one, like I said, is called closed interval. Okay, so or you can call it closed brackets. So, and what is the definition? This one is defined as the set of all x in real numbers such that, say, a, b also. So such that your a is less than or equal to x and your x is less than or equal to b. Okay, so the implication of this one is that your a and b are part of the set. So an example on that is if I have something like closed interval -1 and maybe 3. Okay, so this is the set of -1 less than or equal to x and x less than or equal to 3. So the implication is that this includes -1 and it also includes 3. So from -1 to 3, all real numbers. Of course, it's going to be an infinite set. Okay, and then we go over to the third one. So now the third and the fourth are a mixture of the two extremes. So here you have, it could be half closed, half open, and then it could be half open, half closed. So if we start with half open, half closed, so this is defined. If I have half open a, b, half closed, this is equal to the set of all x in R such that a is the open side is always strictly less than, while the closed side is less than or equal to. So an example is, so this is equal to -1 less than x and then x less than or equal to 3. So in this set now, the meaning is that your 3 is included but -1 is not. Okay, so this is actually what helps us represent what we call uncountable sets. For instance, an uncountable set is different from an infinite set. So a set can actually be infinite yet countable. For instance, if I talk about the natural numbers, okay, so the set of natural numbers, you can actually list them. So a set is countable if you can itemize the elements of that set. For instance, here you can state the first element, the second element, the third, and so on. All right, but when a set is uncountable, it means you can probably state the first, but you may not be able to state the second. But in this case now, for instance, you can't even state the first, because this set is saying that -1 is not a part of it. So that means, what is the first number that is greater than -1? You don't know. The first real number, not the first whole number. So we're talking about the first real number. It could be minus 0.1, minus 0.11. You see there are many of the numbers that you cannot actually pick the first after -1. Okay, so the last is what we call half closed, half open. An example here is if you have half closed -1, 3, and then half open. This is equal to -1 less than x and x strictly less than 3. Okay, so this is what I said to show us in this video. Okay, kindly subscribe to the channel. We'll see you in another video. Bye.